So we're looking at using integration to find areas made by graphs, and there's three different types that you could encounter. Type 1 is the easiest one, where the area is just between the graph and the x-axis, and that's what we're going to look at in this video. So here's an example. We've got a graph, and we've got the area that is made by the graph and the x-axis, and it's this area here that we're looking for. And this is just very basic what integration does. So we need an integral sign, and then the function that the graph has as its actual equation. And then we need to say where we're starting the area. Start at this value of x, so that's here. X is 0 is where we're starting. And then at the top, we say where we're stopping the area. So we're stopping the area here at A. Oh, I don't know what A is, I'm going to have to think about that. So the top one is where we're stopping the area. Okay, so the issue here is where are we going to stop the area? What's happening at A?
The curve is cosine with x.
Excellent. The curve y equals x 4 minus x is crossing the x-axis. What's happening on the x-axis?
Y is 0.
Exactly. Y is 0. So we can sub in y is 0 to the equation, and then we should be able to see it. This is fairly easy to solve. Either x is 0, which we already had, or 4 minus x is 0. So x is 4. So this must be the point 4. This is the point 0 and the point 4. So now we know our top limit as well, 4. That's where the area is stopping. So sometimes you do have to go and do a little job to find out something, but it's not a complicated jobby. So first of all, the C1 bit. Oh no, not even C1 yet. I need to expand out. 4x minus x squared. Okay. Limits still on, don't forget them. And then the C1 bit, big square bracket. 4x minus x. No need for the plus c, but the limits need to appear here. The 1 increases to a 2, and then that's upside down. The 2 increases to a 3, and then that's upside down. So what we've got is 2x squared minus a third x cubed between 0 and 4. So that's kind of the C1 bit done. So the 4 goes in first as x. And then always a minus. And then the 0 goes in as x. Okay, I can definitely do that second one myself. I'm not sure about 32 minus something. 4 cubed divided by 3. 4 times 4 is 16. 16 times 4 is 64 over 3. Yep. Minus 0. I can do that one myself. Okay, equals
32 minus 64 over 3 is 32 over 3.
32 over 3. Okay, well let's check it, because there are too many numbers involved here. So we're going to go to the calculator, and the line that we are using with the calculator, in fact, could be this, before we've even expanded it out. So we can go to option, just to remind you how to do it, option, calc, which is F4, and then integral dx, which is again F4, and then you put in the function, which in this case is x bracket 4 minus x, and then you put comma, bottom limit, comma, top limit, and then exe. And then hopefully we'll get 32 over 3.
Don't get anything at the moment.
Yeah. No. What? Oh, I know why. Sorry. Hang on. We're just there we go. There.
Brilliant.
32. It is right.
It is right. So there's a note to you, don't close off
Yes.
the bracket.
What we had wrong on the calculator is when you press F4 here for the integral, it actually creates a bracket there. And that bracket that it opens itself only closes here. So if you've put other brackets in, like these ones, that's fine, but you have to open and close them yourself. So don't get confused with that bracket that it opens up, that only closes right at the end. Otherwise the calculator gets confused. Okay, let's do some more of these. So, where is our area going to start?
It's going to start at 0 again.
Yeah, it starts here at this point, 0. And where's it stopping?
At our new point A.
Oh, okay, which we don't know. Do you want to do that?
I can do that, yeah. So again, we're looking at where the curve is crossing the x-axis.
Yeah.
So we're looking at where y is 0.
Yeah, y is 0.
So we're going to have 0 equals 3 over 2x squared minus 1 quarter x cubed.
Times everything by 4?
Okay, so 0 equals 6x squared minus x cubed plus x squared.
Yeah, pull out squared.
6 minus x.
Yeah.
So, sorry, x squared is 0,
Yeah.
which is 0, 0.
Yeah, it's a double root. So we've seen that in
Yeah.
graph sketching, haven't we? That double root at the naught where it just touches.
Or 6 minus x equals 0, in which case x is 6.
Yeah, so that must be 6 there. Yeah. Okay, so we're stopping the area at 6, and we're going to build up all of this area like this, and our function is 3 over 2 x squared minus 1 quarter x cubed. And so I will start the integral. So we've got 3 over 2, and we've got a quarter. No need for plus c, but don't forget your limits. Then I'm going to increase that 2 to a 3, stick it upside down, increase the 3 to a 4, and stick it upside down. Bit of tidying up. Half x cubed minus 1 over 16 x to the 4 between 0 and 6. So that's the kind of difficult bit done. 6 goes in first, unless you think numbers are difficult, which I do. So actually this is the difficult bit. So a half 6 cubed minus 1 over 16, 6 to the 4. Have we got a calculator answer?
We do.
What is it?
27.
27, okay.
Sorry.
We're hoping for 27 here. Minus, I'm putting 0 in now. So this is a half 0 cubed minus 1 over 16, 0 to the 4. That's easy, that's just 0. So I've got 6 cubed, I don't
It's
know.
108.
Over 2.
Just 108?
Oh, it already is.
Yeah.
Right. 108 minus
Divided by 60 is 1.
81 minus 0. I can do that one myself.
It's nice with 0.
Is that 27? Yay! 27. Hooray. Fantastic. Okay. These seem to be fairly straightforward, don't they? Do you want to try that one?
Okay. Right, so again, we don't know. Is it B or C there? Doesn't really matter, does it?
B is where we're stopping.
So we're stopping at B.
We're starting the area there, and then going across, and then stopping at B.
Stopping at B. Right, okay.
Which
so
is where it crosses the y-axis again.
Yeah. So we don't know what this point is, so we're going to need to work that one out upwards. So
Yeah.
we want where y is 0. So 0 equals 3x to the half. That's horrible. Minus x to the
Well,
3 over 2.
It is horrible, but we were talking when we were doing differentiation for C1, maybe we were talking about the fact that the indices are really nice for differentiation and integration, but for equation solving,
Horrible.
not so nice.
So I want it in that form,
Yeah,
don't
I think
Yeah.
so. Minus root x in brackets cubed.
And then I'm tempted to just treat those like something like an x or something like that.
Yeah, I think times everything by root x. That's what I would do.
3
Would that work?
x. You're still going to be left with root x here, don't you?
No.
Oh no. Minus x cubed.
No, squared, I think, because what we've got is root x times root x there.
Yeah.
Well, once we times it by the root x, which is x, and then here we've already got root x times root x times root x,
Times it by root x.
and then we're timesing it by another root x. So this is an x, and this is an x. So we're actually going to end up with x squared there.
Yeah.
I think. Do you agree with that?
I do. Yeah, I do.
Okay. Yeah. So
yeah.
so
Yeah, I
we've
like
got.
Yeah.
Yeah. No, that's nicer, isn't it?
That's much better.
Yeah, it's much nicer.
X.
It's just
3
all these
minus
tricks
x.
that you
Yeah.
need really to be able to solve these equations and not panic when you see something like 3x to the half minus x to the 3 over 2 and not know what to do.
So we've got the 0, which is what we wanted, yay, and so B must be 3.
Yeah.
3 okay.
Yeah.
But this is in the form we want it in anyway, so that's nice.
Yeah.
Yeah. Okay, so 3 big bracket x to the,
Calculator it.
yeah, do.
Okay.
Minus
Option.
big bracket.
Calc. 3x the whole. Minus x to the 3 over 2.
3 over 2 plus 1 is 5 over 2, right?
Yeah.
Okay.
Minus x to the 3 over 2.
2x.
From 0 to, where are we going? 3.
3, yeah,
Okay.
3.
Oh, it's having a big think, this calculator.
Right. So now I need to put my limits in.
Oh, it's horrible.
Oh, don't say that. I've got to work this out yet.
Okay, this is what, oh, it's because there's square roots, isn't there?
Yeah.
That's the root 3, and so that's horrible. Anyway, this is what it says, 4.156921938. Should we try and get an exact
I'll try and
answer?
get an exact one, yeah.
I think
That's
so.
2/5 x to the 5 over 2. Well, sorry, that's now a 3, so now I'm putting my limits in.
Yes, 3, yes.
Moment there.
Yeah, and this 3 should be in brackets because only the 3 is to the 5 over 2, not the 2/5. The 2/5 is separate. Yeah.
Minus 2. I can pretty much guarantee I know exactly what this bracket's going to end up being. Okay. So that one's all 0, so that's quite nice. You don't have to worry
Yeah.
about that.
Okay, so that
This
one this is the square root of 3, but then cubed,
Yeah.
and so that is 3.
Yeah, but we've still got it times by 2 here. haven't we?
Yeah.
Yeah.
And then similarly here, that's the square root of 3,
5 times.
but 5 times, so 1, 2, 3, 4, 5. So then that's a 3 and that's a 3. So we've got 9 root 3
Yeah.
there. But then of course that's being multiplied by
2/5 there. I'm still got that minus 0.
yeah.
Minus in there. That's how I'm thinking. Okay, so we've got
Yeah.
2 times 3 is 6 root 3 here.
Yeah.
And then we've got 2/5 of 9 root 3 here.
Yeah.
Which is 6 root 3 minus 18 over 5 root 3.
Okay, well 6 minus 18 over 5 is 12 over 5.
Over 5 root 3.
Okay, so hopefully that 12 over 5 root 3 is a nice way of saying that disgusting thing there. So, calculator, 3, yes,
Brilliant.
4.156921938. But it's much nicer to have the proper answer. Okay. Oh, now this one looks interesting. Where are we starting? So we're starting here at 0, and then we're going up to 2,
Yeah.
but
Some's above the line, some's below.
yeah, some's above and some's below. Now, when you're going across it and you're building up like this, like we've been doing, so
Yeah.
just going from 0 to 1, we've been getting nice answers for area. What you'll find if you then went from 1 to 2, well actually, let's just do 1 to 2 and see what happens.
Okay.
Let's do 0 to 1 first, and then 1 to 2, because they look like separate chunks of area, so we'll do them as separate chunks. Okay, so we're doing x squared minus 6x plus 5, that needs expanding out again, doesn't it?
It does.
Equals the integral from 0 to 1 of x cubed minus 6x squared plus 5x. So now I'm ready to integrate. X minus 6, x at 5, x, don't need plus c but do need to remember my limits. 3 increases to a 4, 2 increases to a 3, 1 increases to a 2, 1 quarter, x to the 4 minus 6 divided by 3 is 2.
Yep.
Plus 5 over 2x squared between 0 and 1. Do you want to calculate this? Because I think I can do it. I'm putting the 1 in first. So this is just that integral from 0 to 1.
Yeah.
1 to the 4 minus 2 lots of 1 cubed plus 5 over 2 lots of 1 squared then minus, then the 0 goes in. 1/4 0 to the 4 minus 2 lots of 0 cubed, add 5 over 2, 0 squared equals 1/4 minus 2, add 5 over 2, minus nothing,
Yeah.
which is something. It's
Well, 1/4.
1/4 add
minus
8 minus 8 quarters, add 10 quarters, minus nothing, which is 11 3/4.
Yeah.
Is that what the calculator
Yeah.
said? 3/4. Excellent. Okay, so that's that bit done. So that little bit there is 3/4, and then we can work on the other bit. So we're now integrating from 1 to 2. It's the same function, x minus 1, x plus 5, which means, to be honest, I don't need to repeat all these steps. I'll just go straight down and steal the integrated function, I think. X to the 4 minus 2x cubed, add 5 over 2x squared, this time from 1 to 2. Okay, so I'll put the 2 in first. 1/4 2 to the 4 minus 2 lots of 2 cubed, add 5 over 2, 2 squared, minus, now I already know what happens when I put 1 in. I put 1 in here.
You did.
That's what that was, which is what that was, which is what that was, which is that. So I already know what that is. That's 3/4. Okay, 2 to the 4 is 2, 4, 8, 16 divided by 4 is 4. 2 cubed is 8 times 2 is 16. 2 squared is 4. 4 times 5 is 20 divided by 2 is 10. Minus 3/4. And that is 4 take away 16 is minus 12, add 10 is minus, minus 2 minus 3/4 is minus a lot. Minus 11/4. Minus 11/4. Okay, is that what the calculator says?
That's what little calculator says.
Okay, now we are right, and the calculator's right, in terms of just doing an integral, but we're trying to find an area here, and there is no way that that area is minus 11/4 because areas can't be negative. So what's happened is, because the area is below and we're going down from the x-axis to pick up the area, down, 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 it's each time it goes down, it thinks it's a negative height. It thinks it's a negative area that it's building up. So what we can do is just say to the algebra, I know you think it's negative, but I want an area, so I'm going to ignore that negative sign. So our area A, the first bit, was 3/4, and our area B, this second bit here, this is like the two little bits of area that we needed to get, that area B is actually 11 over 4,
Yeah.
not negative.
It just kind of almost says to you, I'm upside down.
Yeah.
An area that's upside down,
Yeah.
rather than being an actual negative area.
Yeah, exactly. So that comes out to be 11 to 14 over 4,
Yeah.
which is 7 over 2. Now the trouble with doing it originally all the way, if you integrate all the way from 0 to 2, all the way across, then the algebra includes that minus sign. So what you'll actually end up with is 3/4 minus 11/4, which is minus something, which obviously isn't the area. So you do need to split it into those two separate bits. Okay, last one I think. Do you want to try this one?
I can try this one. Right, so we don't know where A or B is yet, but we know that they're the points where the function crosses the x-axis, which is when y is 0. So I can pop that in. 0 equals x cubed minus 6x squared plus 5x, factor out x squared minus 6x plus 5, which I really hope it does, factorises x minus 1x minus 5. Yes, that does look good. Right, that's all equal to 0. So in this case, x is 0. We've got that one there, that's that one there. We've then got x is 1, which is point A, and x equals 5, which is point B.
Okay, I've just, on the calculator, I've just done the integral from 0 to 1 of that thing, and apparently, unless I typed it in wrong, it's 3/4.
Okay.
So if I just change the limits from now 1 to 5, this should come out as negative. Yeah, it does, minus 32 it says. So it says that the integral from 1 to 5 of that function is minus 32, but I know I want area, so the area is 32. So the total area that we're looking at here shaded is going to be 32 plus 3/4. Yeah, 32 and 3/4, which is, it's always nicest to leave it in a 131 over 4. Yeah.
I'm not very excited about that.
Yeah, 131 over 4. The examiner wouldn't like this. They'd like an exact answer. Yeah,
Which in
always
theory,
an exact
if you
answer.
start to add it up on the calculator, you get to
Yeah. So that's hopefully what we're going to end up with.
Right, okay, so we are integrating first. Actually, I'm going to, oh, that one is labelled. They're labelled R and S, aren't they? So let's,
Oh, okay, I think we're done.
yeah, it's quite nice to keep it that way, because then when you're checking it, you can always go back and check that you've actually done the things the way you want them to. So, minus 6x squared plus 5x dx, which is, big brackets, x minus 6 is x plus 5 is x, no need plus c, do need r, limits, right, 3 increases to 4, so that turns upside down, becomes a quarter, 2 increases to 3, so that turns upside down, third, 1 increases to 2, so half. Should I do that up? It's pretty nice, isn't it?
Yeah.
So the 4 minus 6 divided by 3 is 2x to 3 plus 5 over 2x squared, 0. Sorry. Right.
Oh, I think this is all right. Isn't it?
Let's hope so. Can I just cheat?
Yeah, that's 0, isn't it?
We know that. So that's 1/4.
Yep.
That's 2, and that's 5 over 2.
Which equals 3/4.
Which is 3/4. Perfect.
Hooray. Okay. Shall we rub it out to create room?
Yeah.
Actually, let's not. Shall we just rub it out? Because aren't we going to integrate the same function again?
Well, let's just
So
go
it's only
through
the limits we're
Yeah.
going to change, isn't
So
it? So
take
just-
all this bit out and we'll just change the
Yeah. Yeah,
Yeah.
because it's only. Oh, look, it's
gone small.
gone tiny, tiny. Yeah, because we're doing the same function, aren't we?
So we're actually just changing this lower limit
to 1
to 1
and the top
upper
limit to 5,
5.
exactly.
And we know that that lower limit one is 3/4. Right.
The top, yeah, we need to put the 5 in first.
Yeah, so that's 1/4, 5 to the 4, minus 2 is 5 cubed, plus 5 over 2 is 5 squared, minus that one limit which is 3 over 4.
Yeah, because that was our top limit.
Yeah.
And now it's our bottom limit, but it's going to be the same when you put it in. Yeah. Okay, apparently 5 to the 4 divided by 4 is 625 over 4.
625 over 4,
5 cubed times 2 is 250.
250.
And 25 times 5 divided by 2 is, 125 over 2. Okay, so, and then, so we're doing 625 over 4 minus 250, add 125 over 4, minus 3/4.
Minus 3/4.
Oops, no, I did that wrong. I'm trying to rectify my mistake. I get minus 253 over 4.
Which is definitely not what we...
Oh no,
Wrong.
have we gone wrong?
I think
Well, look,
6 over
the integral, the
sure.
blue bit must be right, mustn't it? Maybe I typed it into the calculator wrong. 5 to the power of 4
625.
divided by 4 is 625 over 4. 5 cubed is 125 times 2 is 250. 5 squared times 5 divided by 2 is 125 over 2. Then, I just must have done something stupid. 625 over 4, unless we really have gone wrong, minus 250,
This is meant to be...
100.
This is meant to be 32, isn't
Apparently,
it?
yeah. Divided by 2 minus 3/4 Oh yeah, minus 32.
It is
fine.
minus
It's fine,
32.
it's fine. I was,
Minus 32.
yes,
Yeah.
exactly. But we know that that's come from integrating from here to here, so the graph is below, and that's why that negative
This is
sign
there,
is there.
yeah.
So we know that the actual area is 32.
Yeah, because its areas can't be negative.
Yeah, because areas can't be negative. Exactly. Hooray.
Hooray!